Turn the page. Let's go to the first one. It says, fill in the diagram below with the following words. Natural numbers, irrational, integers, rational, and whole. So what is the big topic called? All numbers are real. They are either rational or irrational. So we did this one and we did this one. Why did I put rational on this side?
Because rational and irrational can't be the same.
They can't be the same, but why did I choose to put rational on this side and irrational on this side? Rational has what's called subcategories. And its subcategories are these three: integers, whole, and natural. So which one of these would be the biggest topic? Integers or whole? Integers. Integers comes first because integers are positive and negative counting numbers. And then whole numbers would come next, which are your positive numbers including 0. And then the last one, which we kind of didn't go over this year, this was from 7th grade, under whole is counting. That means that you don't include 0 in counting, because when you start counting, you don't say 0, 1, 2, 3. You just say 1, 2, 3. So if that shows up, counting is a subcategory of whole. Okay? All right, it wants us to place these numbers in this part where they would go. So this should be super easy. Where would 0 go? I just told y'all. Whole. Where would pi go? Pi is a famous... Where would pi go? Irrational. Pi is a famous irrational number. Negative 5. Would you count 5? 1, 2, 3, 4, 5? Yes, you would. So it's a counting number, but it's not. These are only positives. So where would negative 5 go? Integer. So it's a positive or negative counting number. 2.4. Would you count that? No. So what is 2.4? Rational. The whole number 8. It's a counting number. It's a whole number. It's an integer. It's rational. 2/3. A fraction. 2/3. Rational, because it's a fraction. The square root of 2. Most likely irrational, but we need to check it to make sure it's not perfect, which it's not. So if I put in the square root of 2, that is not a perfect number. All square roots are irrational unless they're perfect, and it's not. Negative 1/4. Rational. Why is it not an integer? It has a negative sign. Because it's a fraction, and integers are whole numbers, like counting numbers, positive and negative counting. So negative 1/4 is just rational. The square root of 25. Put in your calculator. Counting. Look. The square root of 25 is actually 5, and 5 is a counting number. So the square root of 25 would go here. If counting wasn't there, then you would just put it under whole. Okay? Negative 4.3 repeating. It repeats. That's rational. Why? Because terminating and repeating decimals are rational. So negative 4.3 repeating is rational. All right, we're going to answer these next parts, true or false. Look at your categories if you need to. All integers are rational. Find integers. Is it inside of rational? Yes. So are all integers rational? Yes, that is a true statement. Now, I don't like the way this is worded because it's kind of like no whole numbers. So I take the no off to see what it's saying. Whole numbers are irrational. And then it says no whole numbers. So whole numbers are irrational. Whole numbers are not irrational, are they? So that says no whole numbers are irrational. So it's answering it. It's true. Because no whole numbers are irrational. Whole numbers have to be rational. All right. All irrational numbers are real. Everybody look. All irrational numbers, are they real? Yes. True. No natural numbers are rational. Well, natural numbers, oh, I meant to put natural right here, but natural are counting. Okay? Natural numbers are rational. Are they rational? Are they on the side of rational? Yes, so that was true as well. All right, the next part wants us to place the following numbers on the number line below. So whenever you do this, you just need to put them in decimal form and see which numbers they would fall between. So the square root of 2 is $1.41 if I put it to a decimal. Where would $1.41 fall between on this chart? 1 and 2. Would it be closer to 1 or closer to 2? Here's $1.50. So $1.41 would be like right here. So that's the square root of 2. The square root of 4, if you put that in your calculator, the square root of 4 is actually the whole number 2. So that would fall exactly right here on the 2, the square root of 4. Who knows what pi is as a decimal? 3.14. Where would 3.14 fall between 3 and 4? Closer to the 3. So 3.14, so I put pi right here. The square root of 40, I need to put in my calculator. $6.32. Where would $6.32 fall? Between 6 and 7. And would it be closer to the 6 or closer to the 7? Closer to the 6. And then the square root of 100. Does anybody know what the square root of 100 is? 10. So it would fall exactly on the 10. Super easy? All right, turn the page. Now it wants us to convert these numbers to scientific notation. Who remembers where we go in our calculator? Mode, SCI. So everybody go to mode. Change it to SCI. And then go back to your home screen. Do you type the commas? No. Do you type decimals? Yes. So right here I'm going to type in 3, 6, 7, 8 with 9 zeros. When I hit enter, that's my answer, but we don't write the E. What do we write? Times 10 with an exponent of 12. So my answer is 3.678 times 10 with an exponent of 12. Okay, let's try this one. I'm going to type in 0 decimal, and then I'm going to count 1, 2, 3, 4, 5, 6, 7 zeros. And then 987. Everybody should be doing it with me. How would I write this? How would I write this? 9.87 times 10 with an exponent of -8. Okay, I really want to make sure y'all get those correct on the STAAR test because those are just super easy. Okay, on the next one though, they are already in scientific and they want you to go back to standard. Standard means what? Normal. So I'm going to go back to mode, go back to normal, and then we're going to type it in. Remember that if it doesn't do it, you have to do it by hand. So I'm going to type in 5.98 times 10. Everybody should be doing it with me. And then to get to your exponent, you're going to use your little caret button to the 6th power. And there's your answer, 598 with 1, 2, 3, 4 zeros. If you want to add commas, you always start at the back and just count every 3 numbers. 1, 2, 3, 1, 2, 3. You don't have to. It's the same thing if you don't. Now let's see if the calculator will do this next one or if we're going to have to do it by hand. So we're going to type in 4.37 times 10 raised to the negative 5 power. Did the calculator put that in normal form? No. Why? I don't know. The calculator just doesn't like doing it sometimes. So we're going to go do it by hand by moving this decimal, yes, this many times. So how many times am I going to move it? Since it's negative, I'm going to move it to the left. If it's positive, I move it to the right. So I'm going to rewrite 4.37. And I am going to take that decimal and move it 5 times to the left. So here we go. 1, 2, 3, 4, 5. Here is my new decimal. What goes in the basket? And you've got to put them in the basket. So there are 4 zeros. So you do not want to say to add 5 zeros. This number does not tell you how many zeros to add. It tells you how many times to move the decimal. So my answer is decimal with 4 zeros and then 4, 3, 7. Could I put a 0 in the ones place? Yes. You don't have to, but you can. All right, on the next one it says, place the following numbers in order from greatest to least. So what am I going to put first? The biggest number. To do this, I need to change them all to what? Decimals. All right, 0 is already in decimal form. 50%. How do you change a percent to a decimal? So 50 over 100 is 50 cents. Did y'all notice that my calculator just put 0.5? But I know that in money form, I would add a 0 to the back. Yes or no? Okay, so that is 50 cents. Guys, what is a half? 50 cents. So these are the same value. They're going to go right next to each other, and it does not matter which one I'm going to put first. They have the same value. Does everybody understand? How much money do I owe here? $2.30. Remember, anytime we're ordering, we want to make it look like money. Pi is how much money? $3.14. The square root of 16, you should know it, but if you don't, put it in, is $4. And how do I change a percent to a decimal? Put it over. So if I have negative 200 over 100, that is negative $2. I want to go from greatest to least. So the negatives are going to have to go last. So I'm just going to underline them so I know that I'm not looking at them right now. Out of these numbers, 0, 50 cents, $3.14, and $4, which one is the greatest? So this one's going to go first. I'm going to write the square root of 16 and then I'm going to mark it out. Which one would come next? Look at it as money. Pi. $3.14. So pi. Okay, out of these three, which one is the greatest? $0 or 50 cents? 50 cents. Are these the exact same? So it doesn't matter which one you put first. I'm just going to put the one they put first, so 50% and then 1/2. And I'm going to underline it to say, hey, these two are the same thing and it didn't matter which way I put it. What's the next smallest number? 0. Excuse me, biggest number. And then now I'm going to talk about my negatives. The more money I owe, the less money I have. Which one of these would I owe more money? So this one is worth the least. This one needs to go last because greatest to least. So I'm going to put this one next. And then negative 2.3. Remember, the more money you owe, the less amount of money you have. All right, define the following vocabulary words. What does ascending mean? Going up. So I'm starting small and going up. That's least to greatest. What does descending mean? Going down. That means I'm up big and then I'm getting smaller. That is greatest to least. So what we just reviewed was chapter 1 and chapter 2 from the first 2 weeks of school. I need everybody paying attention. I need everybody sitting up. If you need to stand up, you need to stand up. I will not have anybody sleeping. Now we're going to go on to shapes that are proportional. It says using the information given the diagram below, write a proportion that could be used to find missing side A. Now stop. Are these shapes facing the same direction? Are they aligned correctly? No. How do you know? I know that this angle is the same as this angle. How do I know that? Because they put one line. I know that this angle is the same as this one. How do I know that? Because they have 3 lines, and I know this one is the same as this one. So what did they do to this shape? They just flipped it upside down. So I'm going to redraw it. So I'm just going to go like this. You should be doing the same. I'm going to say, hey, these two are going to be here. This is going to be here. And this is going to be here. This 6.4 came down here. This A is here. This B is here. And now I can take my highlighters or whatever and highlight corresponding sides. This side corresponds with this side. And this side corresponds with this side. Does everybody see what I did? I just flipped it over. Now we need to find side A. So I have to use A and 7. Why? Because they correspond. They're in the same spot. So I'm going to say, hey, I could do A over 7 equals, and then which one would y'all want to use? If we're solving for A, could I use my orange one? No, because I don't know what B is. So I'd have to use this one. 6.4 over what? 8. Why? Because 6.4 corresponds with 8. And then how would I solve this? Cross multiply, then divide. Okay, turn the page. We're not going to do number 2. It's not a good question, but we are going to do number 3. Number 3 says, determine what scale factor. How do you find a scale factor? New over old. Now, it says determine what scale factor was used for the dilation below. Was this an enlargement or reduction? They didn't tell us which one's new and old, so we're just going to go left to right. We're going to pretend this is the old, and this is the what? New. All right, new over old. Somebody give me a ratio to make. 3.5 over 7. Can I put that in my calculator? What is 3.5 over 7 simplified to? 0.5. So what was the scale factor? 0.5. Is this an enlargement or reduction? Why? Because the scale factor is below 1. So it made the shape smaller. Okay, now we're going to compare and contrast the attributes of a shape once you've dilated it. All right, so everybody look at this picture. Which one's new? Which one's old? How do you know the smaller one's old?
Because it does have
It doesn't have the little slashes, the prime. So this is new. This is old. It says, what scale factor was used? Y'all just told me how to find scale factor. How do I find it? New over old. All right, so pick a point. Do y'all want to use A, B, or C?
A.
A. All right, if I use this A, I have to use this A. I need a number for A, so I'm going to go over to the y-axis, and I don't know what number that's at, but I know that this has to be 0, 0, right? Because it's where the two axes meet. So if this is 0, this is 1, 2, 3, 4, 5. This is 6. So new is 6. Old is what? 3. Can I simplify that ratio? Yes. So I go to my calculator. 6 over 3, is what? 2. So what was the scale factor? 2. Using the figure above, what can you conclude about the side lengths of the original shape and new shape? So everybody look at the side lengths of the original. Look at the side lengths of the new one. What can you tell me about them? They're bigger. The new shape is bigger. How much bigger? Y'all just told me the scale factor. They're double the size. They're 2 times bigger. So the side lengths are 2 times bigger. How did I know that? Because I know the scale factor by doing new over old. I should see everybody writing. All right, it says, using the figure above, what can you conclude about the angles? Everybody look at the old angle right here. Y'all see it? Look at the new one. Do they look different or do they look the exact same? They are the same. Why are the angles the same? Because if I change the angles, the whole shape is different. The angles, write it down, are the same. The angles are the same. When you dilate a shape, the sides will be bigger or smaller, but the angles will always be the same. Okay, turn the page. Now we're going to apply dilation rules. It says, take triangle RST, does everybody see it? And dilate it by a scale factor of what?
0.5.
Of 1/2, which is 0.5. So is it going to get bigger or smaller? It's going to get smaller. It wants you to come up with the new vertices. What's a vertice? A point. So I need the old R. Here's the old R. Does everybody see it? I need the coordinate of R. So here's the old R. On the x-axis, where am I at? If this is 0, I'm at 1, 2, 3. Where am I at on the y-axis? 1, 2, 3. Where's the old S at? 1, 2, 3, 4, 1. Where's the old T at? Y'all know what I'm doing, right? Everybody go write the old. The old T is at 2, and on the x-axis it's at -2. Now, we are going to apply the rule which says multiply by 1/2. So what is 3 times 1/2? Put it in your calculator. 1.5. So the new coordinate is at 1.5 comma 3 times 1/2 is 1.5. What will the new S be? What am I going to multiply by? What am I going to multiply by? 0.5, 1/2, because that's the scale factor. 4 times 1/2 is 2. 1 times 1/2 is 1/2. Same thing here. 2 times 1/2 is 1. And -2 times 1/2 is -1. Does everybody understand how we went from the old coordinates to the new ones? You take the scale factor and multiply. Now it says write a rule. Well, what did we multiply by? 1/2. The rule is take your x and your y and multiply both of them by 1/2. You could write 1/2 x, 1/2 y, or you could write 0.5. Okay? Going down to the bottom. What did we learn about slope? If 2 points fall on the same line, they have the same slope. So everybody look. From A to B, the slope will be the same as from A to P. From A to P, it will be the same slope as A to Q. Why? Because they fall on the same line. Is everybody good? Now it says true or false. Line AB and PQ have the same slope. All you need to do is say, do they fall on the same line? So everybody look. AB, PQ, do they fall on the same line? Then they have the same slope. So that's true. All right, everybody find AX right here. Does everybody see AX? Right here. Does it have the same slope? Hold on, how do I get out of here? Does AX have the same slope as QY? No, not at all. They're not on the same line. So that's false. All right, everybody find BX. You'll find it? Does it have the same slope as QY? Are they in the same thing? They are. They are both undefined. Y'all remember slope, dude? So yes, they actually do. That's true. All right, everybody find AB. Does AB and BX have the same slope? No. False. Turn the page. Now we're going to go over graphing proportional relationship, talking about unit rate as slope. Okay? It says, what is the unit rate of Williams road trip? Stop and tell me, what does unit rate really mean? Unit rate means slope. So everybody find William. Do y'all see William right here on this line? Question, is it proportional? Why? It passes through 0. So we need 2 points to find the slope. I'm going to start at 0, 0, and then I see this one. What's my rise? Don't say 3. 0 to? So my rise is 60. What's my run? Don't say 2. 1. What is 60 over 1 simplified to? 60. And what are we talking about? Miles per hour. Now it says, what is the slope of Williams' road trip? What did we just say? Unit rate and slope are the? So what's my answer? 60. Then it says, what conclusion can be made about unit rate and slope? They are the? They are the same. It doesn't matter how they ask it. Unit rate and slope are the same. All right, moving on. Now we're going to look at data from a table or graph to determine the rate of change. What does rate of change really mean? Slope. Very good. All right, it says find the slope. So what to find slope, you need 2 points. What would you use for this? We write it every day on our STAAR chart. To find the slope, either use stat or rise over run. For this problem, what would you use? Rise over run. So here's a dot. I'm going to rise up and go over. And I know y'all can't see the lines good, but here's a line, here's a line. So what's the rise? 3. What's the run? 4. Is it positive going up or is it negative going down? Positive. So the slope is 3/4. What is the y-intercept? Where's the y-intercept at? Where it touches the? So what is the y-intercept? Here's 0, guys. It's not at 3. 3 would be up here. It's at -3. Okay, moving on. It says the following table shows the relationship between flour and milk in a cake recipe. Find the rate of change. What does rate of change really mean? Slope. Now stop. Go to your STAAR chart. To find slope, we either use stat or rise over run. For this problem, would you use stat or rise over run? Stat. So everybody get your calculator. Let's go to stat. Now where do I go? Edit. I'm going to delete anything that's there. And I'm going to type this in. I should see everybody doing this with me, and some of you haven't even opened your calculator. Now where do I go? Stat, calc, option 4. What is the slope? Which one's the answer, the 1 or the 3? The 1. So the slope, the rate of change, is 1. Okay, turn the page. This says 1 inch is equal to 2.5 centimeters. Create a process table below that represents this. So all you do is multiply. 1 inch is 2.54 centimeters, so you multiply to get this. How would 2, what would I do with for 2? 2 times 2.54. What would I do for 3? 3 times 2.54. What would I do for 4? 4 times 2.54. And that would give you your answers. And so we don't have to fill out the whole thing. You would just go down and multiply to get the answer. Okay, look at this next one. It says write an equation. To write an equation, what 2 pieces do you need? I just gave a hint. An M and a B. Stop and look. Is this going through 0? Does that mean it's proportional? Yes, so the y-intercept is 0. So now I just need a rise over run. Now, you can't really see it good because the lines didn't show up, but it's right here. So I went up 92, from 0 to 92, and I ran what? 2. So 92 is my rise, 2 is my run. 92 divided by 2 is 46. Can I write an equation now that I know the M and the B? What would my equation be? Y equals 46x plus 0. Do I have to write plus 0? No. Could I create a table from this? Where would I go in my calculator to make a table? No, to make a table. Y equals, I would type in 46x. And now where do you see the word table? Right here. So I go to second graph. And now I could make a table. 0, 0. I don't even need the process. The calculator's doing it for me. 146. What's the next one? 292. And 3, 138. Okay, turn the page. It says the table below represents how long it took a turtle to walk across a classroom. Write an equation for the table. To write an equation, you need an M and a what? Where can I get an M and a B from a table? Stat. So everybody go to stat, edit, delete your list, clear out your list. And type in your new one, 0, 2, 4, 6. I should see everybody doing this with me. Now that I have it in, where can I go? Stat, calc, 4. What is the M? 3. What is the B? Can I write an equation out of that? Y equals 3x, y'all say it loud, plus 4. That's my equation. Can I graph this myself with this equation? Could you use your y equals button? Could you use slope y-intercept? So let's talk about it. What is the y-intercept? 4. So couldn't I go here 0 and go to 1, 2, 3, 4 and put a dot? Yes? Now, go to your y equals button and type y equals 3x plus 4, and it's going to give you points to put on this graph. Go to your table. Oops, I didn't mean to go to your table. I could put a dot at negative 1, 1. Y equals 3x plus 4. So I could put a dot at negative 1, 1. I could put a dot at 0, 4. I already did that. I could put a dot at negative 2, negative 2. I could also put a dot at negative 3, negative 5. Does everybody see how that works? And then that would be my line that I would just connect it if it asked me to do that. Do y'all know how to make a graph now if you have an equation? Where do you go? Y equals and then go to the table. All right, this next part says decide whether each graph is linear or non-linear. So everybody look at this one. Is this linear? How? Because if I drew a trend line, it's going to make a straight line pattern. That is linear. What about this middle one? Non. What about this one? Linear. This one is it does show a relationship. It's just non-linear because it doesn't make a straight line. Turn the page. Name the type of trend or association for each of these graphs. So what kind of trend is this if it's going up? Positive. What kind of trend is this? Negative. What is this? None. No association. So they might say no trend, no correlation, or no association. They might say any of those words. Okay, number 2, create a trend line for the graph below. How do you create a trend line? Follow the dots, but have just as many dots above as below the line. So if I wanted to make a trend line for this, I want to follow the dots, but I need just as many dots above my trend line as below. So you can see I have quite a few dots above, quite a few dots below. Yes? Then it says, using the graph above, about how many quiz items would a student get correct if they got 5 homework items correct? So here's correct. Does everybody see that? So why am I going to go to 5 on the y-axis? Because it said correct. So I'm going to go to 5. I'm going to go over and down. About how many would they get? About 5. Okay, turn the page. It says, Devin's parents live in Austin, Texas, which is 780 miles from Devin's home. If Devin averages 60 miles per hour, did y'all hear that? How long would it take him to get from his home to his parents' house? Could I write an equation out of this? 60 miles per hour. How would you write that? Y equals? 60x. We don't want this in our equation. It's just a proportional. That's just how far away they live. Then you would fill out your table. How would you fill out your table? In your what button? Oh, look at this. In your y equals button. So you would go to y equals and type in 60x. And you would go to your table. When x is 1, y is 60. Do y'all see it? I'll zoom in. When x is 2, y is what? So 2, 120. When x is 3, y is 180. And I mean, you could keep going. When x is 4, y is 240. When x is 5, 300. When x is 6, 360. But what did they ask? How long is it going to take him to get from home to his parents' house? How far away is his parents' house? 780 miles. So look, if I just keep scrolling, do you see 780? It's going to take him 13 hours. And all I did was use my table. So 13 hours. Then right here, we're going to stop at this question. It says, using the table above, write an equation. We already did. What was our equation? Y equals 60x. Why did we not include the 780? That was part of the question, not part of the equation. Okay? Now what we're going to do is you're going to put your name on this. You're going to pass it to your right. I'm going to take it up. And tomorrow we're going to finish as many as we can.